The atomic theory, the history of atoms. What is an atom? An atom is the basic unit of a chemical element. An atom is the smallest unit of matter that defines the chemical elements. Every solid, liquid, gas, and plasma is made up of neutral or ionized atoms. Atoms are very small. The size of atoms is measured in picometers, or trillionths of a meter. The history of atoms. It is common knowledge that atoms are the building blocks for all matter. However, it took many years, a few scientists, and a great deal of experiment and discovery to reach this conclusion. The idea of atoms and their existence has evolved over the years. This is known as the atomic theory, which is essentially the history of the atoms we know today. Democritus. He is an ancient Greek philosopher, and he's known for the first atomic theory. He claimed that everything is made up of atoms. These atoms are physically, but not geometrically, indivisible. Between atoms lies empty space. Atoms are indestructible, have always been, and will always be in motion. There are an infinite number of atoms and kinds of atoms, which differ in shape and in size. He said about the mass of an atom, the more any indivisible exceeds, the heavier it is. He helped to propose the earliest views on the shapes and conductivity of atoms. This is a picture of what Democritus' atomic model might have looked like. Aristotle. Aristotle was a Greek philosopher, alive and practicing at the same time as Democritus, but he rejected the atomic theory. Aristotle believed that atoms did not exist. He believed that all matter was continuous from one surface to another, and he also believed that all substances were made up of earth, wind, water, and fire. He taught these beliefs and was very famous for his teachings. Here we have a picture of his atomic model, or lack thereof, because he did not believe in the atomic theory. John Dalton. He was a scientist. Many years after the ancient Greek philosophers, Dalton composed his contribution to the atomic theory. He proposed that all elements are composed of indivisible atoms. He also claimed that atoms from different elements can bond together to form compounds. His theory explains that each element has a unique chemical behavior, mass, and size. Although his atomic model looks very similar to that of the ancient Greek, he found more things about their chemical composition and the components of atoms and elements, which were very different from that of Democritus. J.J. Thomson was a British physicist. He is responsible for discovering the electron. He discovered the electron in a series of experiments designed to study the nature of electric discharge in a high vacuum cathode ray tube, an area that was being investigated by numerous scientists at the time. He proposed that atoms contain negatively charged electricity known as electrons. In a sea of positive charge, his idea of the atom is called the plum pudding model for its appearance. Thomson was also the teacher of Ernest Rutherford. Here you can see his atomic model and how it looked like plum pudding, with the positive pink circle being the pudding and the blue electrons or circles being the plums. Ernest Rutherford was an experimentalist and scientist. He is responsible for the discovery of an atom's nucleus. He proposed that atoms consist of a small, dense, and positively charged nucleus. This nucleus has electrons orbiting around it. Through his gold foil experiment, he made this discovery. This experiment showed that when alpha particles are fired into gas atoms, a few are violently deflected, which implies a dense, positively charged central region containing most of the atomic mass. Ernest won a Nobel Prize in chemistry and also taught many future winners. This is an example of his atomic model. We can see that it's different than the others because of the black dot in the middle, which represents the nucleus, and the red dots around it that represent the electrons, not floating in a sea of positive charge, but orbiting around it. Niels Bohr. He was a scientist and physicist who won a Nobel Prize for his contribution to the atomic theory. He created the atomic model, which determined that electrons are not just floating outside of the nucleus, but they lie at specific distances from the nucleus. The farther they are, the higher the electricity, and vice versa. He was one of Ernest Rutherford's students. And here we see his atomic model. Clearly, it's different from that of Rutherford because the electrons are at specific orbits around the nucleus instead of just floating free and on their own. Here is a video of the view of an atom under a microscope, and it is courtesy of YouTube.
Have you ever seen an atom? Seeing as everything's made of them, you have, but have you ever seen one on its own? Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small. Traditional light microscopes can be used to see things like these onion cells and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe far smaller things. Using beams of electrons instead of light, we can generate detailed images of chromosomes themselves. Recently, groups of scientists around the world are becoming able to see materials at the most fundamental scale, the atomic. One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms. But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom. The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry.
So in this video, we're seeing kind of a continuation of the history of atoms. It's not maybe new scientists discovering something about the atom, but they're discovering new ways to see the atom and use them in our lives. Today we know that everything is made up of atoms, and that those atoms have four components: a nucleus made up of protons and neutrons, and electrons that orbit about the nucleus. Without these scientists and their contributions to the atomic theory, we would not have this knowledge. Thank you for watching.